Hello and welcome. This is a M1 past paper, Mechanics 1 past paper for Edexcel. This is November 2002, so I'm right from the back of the backlog of past papers. The first question is quite a nice one, really. It's nothing too extreme. It's just a use of, well, the main problem with this question was understanding what it was actually saying. That's the hardest part I found about it anyway, so anyway, okay, so I'll just draw out what we've got given. So this is a point on the wall that the string is fixed to, and it looks something like this. So you've got a point on the wall, we call that O, we said that was O, sorry, on the thing, an angle of 30 degrees, and a point P, where the particle is that we're going to consider in this question, and it's being pulled by a force F in terms of newtons. Okay. So the particle, we're told, has a weight of 6 newtons, so we don't need to do anything with that, we don't need to times by anything because the weight is a force, so we can leave it in 6 newtons. And obviously this force keeps it in this equilibrium state. Now, as soon as you see the word equilibrium, you should be noticing a few things on your diagram. Well, you should be noticing a few things on your diagram. If it's in equilibrium, then obviously the force upwards is going to be 6 newtons as well, and this force going the other way is going to be equal to F newtons as well. Okay, so we are asked to work out the tension in the string. Now, using the idea of parallel angles, you can, so way back in GCSE this, you should know the angle there is also 30 degrees. So we've still got a sort of right angled triangle here. What we want to know is the tension, which is that there. We want to know what the tension in this O to P is. This is essentially what we're trying to find out. We know the angle, we know what the adjacent is. So what we're going to use is, we're working with the hypotenuse and the adjacent, so obviously we're going to use cos. So therefore you write, I do for part A, you write T times cos 30 is equal to 6 newtons. Rearrange this so you say, okay, T is equal to 6 newtons over cos 30, and that should get you an answer which is equal to 4 root 3 newtons, or if you were to put it in decimal places, 6.93 newtons. Okay? So that'd be your answer for part A. All we've done is use basic trigonometry there. Okay. So the value of F. Well, if it's in equilibrium, we can count out the vertical forces now. We just can worry about the horizontal ones. Well, you can put T is equal to 6.93 on your diagram if you want to. You don't really need to. Well, you sort of do, I guess. Yeah, you do. So what we're trying to work out is this F newtons going along this way. Because we're told it's in equilibrium, the force pulling it backwards in the opposite direction has to be the same magnitude. So we can sort of work from this as sort of a right angle triangle now. So if we join this up to look like a right angle triangle, so we've got the theta, 90 degrees there. So we know the hypotenuse, we know the adjacent. We want to know the opposite, the angle. This bit here is O. As we say, this line up here is going to be the same as the force down here, because it's in equilibrium, so it's going to be the same. So therefore, we just again use basic trigonometry. So for B, instead of cos, we're going to use sine. So, and instead of T, we're going to put 6.93 because that's what T is. So 6.93, or you could put 4 root 3. Or you just copy your answer, because it's part B, so you're going to have the answer in your calculator. You just be lazy and press answer times sine 30. And that's going to give you an answer equal to do this. Sorry. 6 over cos 30. Make sure you calculate it in degree mode. So otherwise you'll get a stupid answer and you know it's wrong. Times sine 30. And you should get 2 root 3, half. Because sine 30 is a half. Which is obviously 3.5. Or 3.46, whichever, only it was 3.46, because that's what's into the one. Okay? Right. So that's part A and B. Of question 1. Oh, that's all there is. So question 1 was a nice 6 marks. All it was, as I said, the hardest bit of realising that P, that's where the particle actually was, and to be able to do this trigonometry idea, it's really just testing your understanding if, do you know what equilibrium actually is, in terms of resolving forces. But as I said, that's a very simple question. It's a nice 6 marks on the exam, especially the first question. It's going to be something too strenuous. So anyway, I hope you understood that. Just a bit of an introduction to November 2002. Hopefully we'll see you in question 2. So thanks for watching, and well done for making it through.